Mario once again with MIA Microflight. In this video I'm going to be discussing how to make a simple solenoid bumper for a pinball machine. You can see there's a pinball machine right underneath here. This is my pinball machine that I've been building and experimenting with. So in this video I'm going to be showing you how to make a simple solenoid bumper. In one of my earlier videos I did another bumper, which is one of these guys right here, and this is a little more elaborate. So if you want to watch that video, go to my earlier videos on the subject of pinball machines and watch that video, and you'll see how I did that particular bumper. This one right here is going to be a little bit easier, and it is for somebody that just wants to do this quickly. I originally had done something similar for my my first experimental bumper, and I wasn't too happy because I was getting these sparks, and I think it's because of the way that I was triggering the solenoid. Since that time, I've done a little more experimentation and modification to that setup, and so I'm going to show you what I did here. What I'm using to trigger the solenoid is this MOSFET. This is I don't remember the particular value of this MOSFET, but it's a MOSFET IC chip that comes with these circuit boards. You can buy these online. There are a lot of companies that sell these for, you can get them, for about $1, maybe if you buy them in packs of 5, or they go a little bit higher. But very useful small circuits, to trigger these solenoids. What's in this circuit board is basically the MOSFET. It's got some terminals here to connect your inputs and outputs, and also it's got these this 3-pin setup here, for signal so that you can trigger this this driver, so it triggers the solenoid. I will show you this in the circuit diagram in just a little while here, but basically what happens here, and I'm just going to do this real quick here. This is sort of a really quick and dirty setup here, the way I have it here, just to explain this what's going on here. So the concept here is to reuse this metal bell here, or the hat that comes down, when this is triggered, and kick the ball away. But there's got to be some kind of a switch here between this plate right here and another metallic plate that is part of that sits on top of the table. So when the ball comes in contact with that plate and the metal part on the surface of the table, it switches the solenoid, and what happens is you get that effect right there. Now notice that I have 2 LEDs connected, and those are in series with the switching here, so that when you get the switch, it not only sends that signal to this trigger here on this signal pin, and that is what is actually doing the triggering on you can see the circuit's triggering and the solenoid's triggering here. So I'm sort of mimicking the ball making that contact, making that switch here. You'll notice that let's see. Okay, so in order to achieve that switching, we have to connect one of the wires. One of these wires needs to be connected to this plate right here. And so what I've done is I've connected. Well, it's not connected right now, but I had this connected a little bit earlier. So one of these has to be connected to that point right there, and the other one has to be connected to the surface, the metallic surface on the pinball machine base, so that when the ball makes contact between this pin or lead that's connected to the surface makes contact with this plate right here. In other words, it's making contact like that basically, but it's going through this plate and the surface that's going to be connected to this lead right here. It'll make contact and it'll trigger the solenoid. So basically, I'm going to show you what that looks like in the following diagram. So basically, that's what it's doing. Okay, I had to switch off my power supply so I don't burn anything here. We don't short anything out here. So the circuit diagram for this solenoid, this very simple solenoid, is basically I just explained. It's the solenoid is connected. It's connected to the solenoid is connected. It comes to these 2 points right here, and those 2 points are labeled on these circuit boards V plus and V minus. This diode right here is to prevent any high voltage returns, to the circuit, and so that kind of shuns the high voltage that happens, when you activate coils on and off, and so that needs to be there. The Vin on this terminal here is basically the 24 volts DC, and this other one is ground. So I'm connecting my 24 volts to these points right here. This is what you're seeing here, the red and this is actually black here. It's got a red stripe, but it's black. It's the ground. So that's what you're seeing here in this circuit diagram. This trigger right here is the signal. I'm using that back from the switch. So when the contact is made by the ball between the metallic surfaces of this hat here and the surface, which is going to be connected to one of these leads here, when that makes contact, basically you're effecting a sort of a switching attitude here, or it's like making closing a switch here. So when that happens, you're sending the trigger here to the circuit, and the circuit actually does the triggering of the coil. Basically, that's very simple. That's what's happening. I have 2 LEDs here in series, and the reason I have 2 LEDs in series is because I'm using 24 volts here to drive this loop here. And these are 12-volt LEDs, so it's a way to sort of distribute the voltage between these 2 in-series LEDs so that I don't burn them. And so that's how this circuit is working right here. You can see one of the wires is connected, okay, to one. One of the wires is connected to this point right here, as I showed before. In my in the circuit right here is connected to the bottom of that bottom of this shaft, and that is because you need to establish a point of contact between the electrical point of contact from this point to the hat, because the ball has got to hit the hat, and then the other side of the ball has got to hit the surface of the table, which in this case I'm showing is an aluminum sticky back sort of tape or surface, so when the ball comes in contact, as you see it here, it switches on it connects this point right here to that point right here, and that's what I'm showing over here happening, through this sort of illustration here. This switch is really not there, but I'm illustrating the switching action, of the ball making contact between those 2 surfaces there. The circuit, the electronic circuit for this circuit right here is this right here, and you can see the MOSFET is set up with the drain connected to the solenoid. The solenoid is in parallel with this protective diode. That's what I showed right here, that diode, and you'll see in this circuit also, circuit board, you can see the diode right here with the anode on this side and the cathode on this other side. So anode, cathode. Anode is the arrow, cathode is the bar. So that's what I hear here. The bar is on this side right here with the circuit. 24 volts right here, ground, as I said, and then the signal or the trigger point right here. It's real simple, real easy once you get this assembled, and you play around with these things. But I thought I include this, for anybody that's interested in getting all this, because it took me a little while, to get all this information online. I had to go and do a little bit looking around just to grab, all these, how this is connected. I actually reverse engineered this when I got the boards. I started looking at the circuit board and testing the pins, and I actually formulated my own diagram, my own actually circuit diagram from that. But you can find these things online, if you look for these things, with a little emphasis. It's not readily available, and depending how you search, you'll find it right away, or it'll take you a little time to find these things. But basically, that's the circuit diagram. The trigger signal is connected to the gate in line with these resistors. These are 1K resistors. One is connected to ground, the other one is connected to this LED. That's what that little tiny LED that blinks on and off is part of the circuit right there. There are the two resistors right there and the LED right there, and so that's part of this the circuit right here. The source is connected to ground. The drain is connected to the V minus. So if you were to look at this right here, if you were to trace, this MOSFET right here, the drain right here, that's why I drew this line right here, is connected to the V minus. So this would be V minus, this would be V plus. Makes sense if you understand electronic circuit design. So that's the electrical components, electrical circuit, and the way this is set up right here. Now let me explain how I made these parts. For anybody who wants to make this, I was contemplating making this as simple as possible, and that's why I did it the way that I'm going to show it here. Now you can see that this part right here is a brass tube that has been press fit over the existing shaft of this particular JF0730B, 24 volt, 300 milliamp, 5 Newton solenoid. I'm using 24 volts because you get a much better kick out of these at a higher voltage at a lower current. It's more efficient that way, instead of using 12 volts and then your amperage is higher. So that's the reason why I'm using 24 volts. If anybody's wondering, here's my solenoid. Like I was saying, this is the brass tube that's been press fit over this shaft. This is a 6 millimeter brass tubing that just happens to fit over this shaft here, and that's why I used 6 millimeter here brass tube. This is basically just a washer that I made it into a conical bowl like shape. And the way I did this, both of these things, even the brass tubing has to be flanged, and so you have to manufacture that, unless you have something similar that you can use. But basically, because it's very hard to find exact parts, I just did it myself. So I'm going to show you how I did this. I took the let's start with the washer because that's the easier one. So I took a washer that's 1 1/4, 1.5 inch in outside the diameter with an approximate 6 millimeter ID hole, just a flat washer. Then I put that washer on top of a PVC tube. I believe this is a 3/4 inch PVC tube. Actually, it's a little bit bigger than that, so it holds the washer almost with the edges aligned with the edge of the PVC tube. And so you want to support. Basically, this is acting as support that is not going to let the washer fall through. And so this has a wall thickness, obviously, because this is a PVC tube. So that's actually supporting the edges of the washer. So on top of this washer, I lined this with a 1-inch steel ball right on top of the inside diameter hole. And then I put this on a press, a 1-ton press, and I pressed it, and that created my bowl shape here that you see here. Basically, this hat, this metallic hat. So that's how I did this top washer. Now for the tube, for the brass tube, I took a brass tube. This is about let's see, it's about 3/4 of an inch in length, and you can see I soldered that to the washer at the top of inside of the hat or this bowl. I'm calling it a bowl because it looks like a bowl. And so in order to do this flange right here, I took that 3/4 inch length brass tubing, and I shoved it on the size washers because it just happens that it fits nice and not too tight, but a little bit loose inside this inside diameter of the washers. And I took a bunch of washers, stacked them up, so that it acts as support for the tube. I don't want without these washers, the tube would compress, like an accordion, and so you don't want that. So you want to retain that a good portion of the tube, and just about maybe a 1/16 of an inch sticking up. Above the top washer, which will allow you to compress this with another steel ball. In this case, I use a 1/2 inch steel ball, and I use it once again. I put this under my 1-ton press and came down with a press nice and easy, and it created this flange. And that's basically how you create these shapes. Using these stock. Very easy to get components. You can get these at a hardware store, or so that's how I did these forms right here. Once I had these two formed, I stuck this brass tubing inside the washer. Of course, before you do that, you have to prep these areas here. And what I did here is I sanded this washer. I sanded it really well. And then I took alcohol and I cleaned that really well. Same thing right here. I sanded the brass tube really well. I cleaned it with alcohol, and then I came back with a I came back and I primed that with a flux, solder flux. I put a little bit of flux there, I stuck this inside there, held it on my vise, soldering vise, and I I soldered this to the washer, and that's how I ended up with this setup right here. This connected to this the stem, and so I just press fit that over this the shaft here, and I can probably just undo this. There we go, because it's just press fit. I didn't want to weld this. I don't want to solder that to this part right here, because I don't want to ruin this shaft. And in case I need to replace that, it's real easy. So I just pressed it. It goes really nice and tight there, and it stays, because this is basically doing a pull down action. When this thing is in action or triggered, and the spring is very lightweight, that it's not going to kick it out of that press fit. So that's how I'm doing the very simple solenoid trigger or bumper. If you want to do something similar, you can do the same. The only thing is that when you mount this on the table, you're going to have to have some kind of a where is that piece? You're going to need, hold on a minute. Okay, as I was explaining, you're going to need some kind of a metallic surface, so and connected. This has to be connected to the wire that's going to the signal of this circuit board right here. And the other wire has to be connected to the center or the shaft here at the bottom, because the shaft is connected via this setup right here to the hat. And so when this and that makes contact via the ball, you're going to get a trigger. You're going to get that sort of trigger right there. Let's see if I can. It's a little difficult here on this table here, but when that makes contact with that, you get that trigger. Actually, it's not triggering. There you go. So you get the point here. I don't want to do this too much, because it's not a clean setup here, but you get the idea here with the metallic aluminum tape that I'm using here. You can use copper. Copper would be better, because it's a better conductor than aluminum. And so let me add this. There's a little machine. There's a they call it a three-dimensional pinball puzzle. It's made by a company by the name of Roker, something like that. There's so many of those machines that people have built, and you can find those online. YouTube channel has a lot of those videos, and they use a similar setup to this solenoid here, except that they're using these little tiny solenoids. I built that machine, and I noticed that it's using the same concept here. And I was actually thinking about this way before I started building these machines, because this has been on my mind, building a pinball table for a while now. I started I started itching to build one of these back in mid 2024. I just did not have the time, and so this year I started building this machine. And so some of those ideas, some of those thoughts that I had, as far as the so just trying to keep everything simple, has come back, and this is the reason why I'm doing this video as well. But combination of that, I'm going to build a few of these just to add a few more triggers here. Combination of that and these that are like the full scale ones. These are a little more complex because they use an internal trigger switch. That it's my own trigger switch, but it's built like it's built more like the full size traditional bumpers that are used on pinball machines. So anyway, this is Mario with MI Microflight. If you have any comments, just put them down below, and I'll be doing some more videos. As this project that I'm working on here progresses, I'm doing this, in my spare time, so it's rather slow, but I'll be posting a lot more as I continue working on this pinball machine. Basically, you can see that I got the bumpers, I got the I got some trigger points right here. These are just switches right now. They're not connected to any solenoids, but I could connect these to solenoids so that it kicks the ball back, as that switch gets hit. Right now it's just switches and lights. But I am working on some electronic circuits to complete the lighting here, the counting sequence and the scoring. So that's going to take me a little while, but eventually I'll get to those. Thanks for watching.